Hello, welcome to Math 1324. This is Chapter 4, Section 2, the first example in Section 2. In this question, we want to answer, we're given an initial simplex tableau. So the initial simplex tableau of a linear programming problem is given. Use the simplex method to solve it. Okay, so here we're given the variables x1, x2, x3, the slack variables s1 and s2, and the objective z. And of course this is the equal column. Now here's the thing. We need to first identify what an indicator is. An indicator will always be in the bottom row excluding the number here that represents the objective or the equal. So only the regular variables and the slack variables. So those numbers are indicators. So what we're going to do is we need to find what's called a pivot. A pivot is going to be a number that we're going to make to be a 1 and everything above and below a 0. Okay? So to find the pivot, the first thing you're going to do is look for the most negative indicator. Now in this case, we have a negative indicator of -5, -50, and the others are either positive or 0. We don't worry about those. Now, if you're done, if you have no more negative indicators, you're done. But what we're going to do here is we're going to look at the most negative, which is that -50. Now, since -50 is the most negative number, that means that this is in fact my pivot column. So to find the pivot column first, you look for the most negative indicator. If you have two indicators that are the same negative value and they're the lowest negative, the smallest negatives that you have, then you use the one that is furthest to the left. In other words, if this was a -50 and this was a -50, I would have chosen this one instead. Okay, so what we know now is that this is the pivot column. But that means that there are two different possibilities. We never worry about the bottom row is never a pivot row. It's just a question of, is this one or this one a pivot row? So to find the pivot row, look for, first of all, divide the equal column number by the pivot column number. Okay, so to do that, 8 divided by 2 is going to give me a 4, and then 10 divided by 10 is going to give me a 1. And it's at this point we need to decide between which of those two. Between those two, I want the smallest number, I believe. Smallest? Yes. Give me just a second. Okay, so yes, it is in fact the smallest number that we want. And so because when we did this division, 4 was here, 1 was here, that means that the second row is the pivot row. Okay, and then so for here, look for the smallest quotient. There we go. The smallest positive quotient, by the way, I should emphasize that. Sometimes you'll get negatives here or even 0. Or if it is undefined, it's not that one. So don't worry about that. So what we have now is we have the pivot column, we have the pivot row. Now the intersection of the column and row will actually tell us the pivot. So row 2, column 2 is our pivot element. So the pivot here is row 2, column 2. Okay. Now this is the initial simplex, or excuse me, this is the simplex method. And at this point, once we have indicated that this is in fact the pivot, what we're going to want to do now is turn that into a 1 and everything above and below a 0. But that's while we have the pivot program on the calculator. That's what it's going to do for us. Okay, so let's go to our calculator and figure that out. I will see you there. Hello, welcome back. We are at the calculator, so let's go ahead and type this in. Go ahead and go to second matrix. Go right to edit and edit this. This is a 3 by 1, 2, 3, 4, 5, 6, 7. 3 by 7 here. So 3, enter, 7, enter. And then let's just type in these numbers. 1, 2, 4, 1, 0, 0, 8. 4, 10, 1, 0, 1, 0, 10. Negative 5, negative 50, 1, 0, 0, 1, 0. Good. Now let's go ahead and quit the home screen. Just to check ourselves, I like to go ahead and just type in matrix A to make sure what you see here is what you see for your initial simplex tableau. 4, 1, 0, 0, 8, 4, 10, 1, 0, 1, 0, 10, negative 5, negative 50, 1, 0, 0, 1, 0. Okay, good deal. Now, this is where we start using our program. So go to program, and then here you have pivot. Notice it just says program pivot. Just click enter. Now, what it's showing you is it's showing you the matrix in matrix A. That's all it's doing right now. Click enter once. Now it's asking you for the pivot row. In other words, which of these rows should I choose? The pivot row is the pivot number, or the pivot row number 2. So it's the second row in the matrix here. The pivot column will be the second column. So I'll do 2, enter. Good. Notice it says done. Okay, so let's go back into matrix and look at what happened. We have a matrix here, and now we also have a matrix here. We've got a matrix here and here. So let's look at both of these. If I look at B, B is the exact same as the original. Because what's happening is I am, in my matrix, I save the initial simplex tableau and I put it into B. And then I change stuff around, and A is the new pivoted, whatever, column, yes. So just to see it in fraction format, here we go. Notice that that number 10 has now become a 1, and everything above and below is now a 0. That's fantastic. That's what we want. And believe it or not, we're done, because if you look at the indicators, the 15, the 0, the 6, the 0, the 5, notice the 1 and 50 are not indicators. These are all non-negative, 0 or above, basically. So it means that we're done. This is all. This is the simplex method. Now, I'm going to go ahead and write that down on my paper. We have 1/5, 0, 19/5, 1, negative 1/5, 0, 6. Then we have 2/5. If I can write down the number 5. 1, 1/10, 0, 1/10, 0, 1, 15, 0, 6, 0, 5, 1, 50. Alrighty. Well, there we go. I'll see you back in the notes. Welcome back to the notes. Notice all I did is I wrote down the simplex, the tableau here. Now, here's the thing. I have not written what the variables are. Remember, the variables in this case are written above as x1, x2, x3, s1, s2, and z. Now, of these, which ones are 0? Remember, only columns that have a single number that's not 0 and zeros above and below will be not 0. So lots of numbers. This column is all 0. Lots of numbers here. This column is all 0 as well. Lots of numbers here. This one is all zeros. And the equal column is never a 0. Okay, good deal. Notice what's happened. If I was to write down x1, x2, x3, s1, s2, and z out of all this, I can write down everything from this. x1, x3, s2 are all zeros. Now, if you look here, x2, it has a 1 right here, right? And notice that the stuff that's not highlighted are all zeros left over here. So it's just 1x2 equals 1. So x2 equals 1 here. As for the s1, the 1 is right here, equals 6. And the z, the 1 is here, equals 50. And there you go. That's the solution. That's all it is. That's the fantastic thing about the simplex method. And this was a 3-dimensional simplex method. Love it. Alrighty. Well, I believe that that is it for this. Yes, use the simplex method and solve it. Alrighty. Well, I'll see you in the next video. Have fun.